Hello and welcome to Jason Live. My name is Patrick Shea. We're back once again with our STEM career series where we learn about careers in science, technology, engineering, and math from role models working in those fields. Today's role model is Maura Hahnenberger. Maura is a meteorologist and atmospheric scientist. Her research focuses on how to improve the forecasting of dust storms so people will know when to stay indoors and avoid the negative health effects of breathing dust, which, trust me, is not as much fun as it sounds. We're going to learn all about that and more in just a moment when we connect with Maura. But first, I just want to remind everybody out there that today's event is live and interactive. We're going to be answering your questions and asking you to participate in our polls. To do both of those, just use the box right below this video window. Right now, it's time to get Maura into the program. Welcome, Maura. Thanks for joining us.
Thanks for having me.
Awesome. So our students out there have already started sending in questions even before the event started, so we've got a lot to get through, and we're going to start with one here from, if I can find them again, Megan and Liesel. And they want to know, what do you do as a meteorologist? We're going to start with the basics here. What do you do as a meteorologist?
So I'm one sort of type of meteorologist. So my job right now is I'm a professor at a community college. So what I do as a meteorologist is actually a little bit different as what most meteorologists do. So what I do as a meteorologist is I teach classes about meteorology to college students, and I also do research in meteorology. So I go out in the field, I collect data. I also have data that we collect online from people who've already put out instruments, and I bring all that information together to do scientific research. But actually, most meteorologists, their day-to-day job is forecasting the weather. And I have done that in the past, but that's not part of my day-to-day job right now. And so they take all of that scientific data and weather data that's out there, and they make daily weather forecast. So I'm probably not the typical meteorologist, but what I do is fun as well.
Well, I'm glad you mentioned fun because we have a couple of related questions here from Samantha, Rebecca, and Navia. What do you like about your job, and what is fun about being a meteorologist?
So being a meteorologist is, I think, one of the funnest jobs because every single day things are changing outside. So every single day when I wake up in the morning and I go outside, I get to do my science. I get to look at the sky and try to figure out why there's clouds, why there's rain, or why there maybe is dust in the air that day. And so that's the funnest thing for me is that the weather is always changing. So there's always something new to ask questions about and learn about and then talk to other people because most people like to talk about the weather. So that's really fun.
So we've got a question here, kind of along the lines of just basic meteorology stuff. This question is from Don. He wants to know, what's the difference between climate and weather? So you say everybody loves talking about the weather. There's been a lot of talk about climate recently, too. How do those, are they the same? Are they different? How do they match up?
That's a really great question. And so I like to think about weather as sort of what's happening right now. So when I go outside today or tomorrow and I see that it's raining, or maybe now that it's getting to winter, that it's snowing, that's really what our weather is. It's our day-to-day changes and what's going on in the sky and in the atmosphere. When we think about climate, really what we're thinking about is longer periods of time. So where weather is, a day or a couple days, for climate, we're thinking about many years. And usually we want to think about maybe at least 30 years. So that's a long time. But that may go even longer. So we may be thinking about hundreds of years or thousands of years. And the climate is sort of if you take all of the weather conditions over that 30 years or 100 years or 1,000 years, and you average all of that together, that gives you information about the climate of that area or maybe even the whole planet. And so it's really a difference of that time, whether we're looking at short periods of time or long periods of time. And then we have that in between time. So we have a couple days and then many, many years. And in between that, we have sort of what we have small changes in climate, or variability is the word we usually use, which is sort of changes within a climate over sort of multiple or a small number of years.
Great answer to a very complex question, really. We've got a couple of questions here that are going to get a little more into the kind of research that you're doing specifically as a meteorologist. Matthew wants to know, what projects are you working on right now? And McCrae wants to know, what kinds of storms do you study?
So the projects I'm working on right now are about dust storms, and I study dust storms in the western United States, specifically in western Utah. So I'm located in Utah, and the western part of Utah, we have the Great Basin Desert, and the Great Basin Desert is an area that has a lot of dust storms. And so I go out into the field and I collect dust samples. I also use a lot of data from satellites. So satellites up in space that look down and look at the atmosphere and the surface of the planet. And I use that data along with weather data to try to study where the dust storms are, what's causing the dust storms, and who is being impacted by the dust storms. So the dust storms I study are caused by storms called cyclones. And these are cyclones that happen in sort of the middle latitudes of our country, or around the world, really. So not down in the tropics, but down up for sort of further north. And these cyclones cause really strong winds that cause these dust storms. And this is the video that was just playing was a dust storm that happened in Texas just a couple of years ago. And it changes, you can see really quickly as that dust comes in, you see that it gets really hazy at first. So here comes the dust, and then you get basically no visibility. It actually turns red because the dust in that area is actually a little bit red. So not something you want to really be hanging out in.
Yeah, that looks really intense. And we're going to come back around to dust storm stuff in a moment. But Jackson has a question right now. He wants to know, is there math in your job?
Yes. So I actually use math a lot in my job. So the atmosphere or the sky is really is what we call a fluid, which usually when we think of a fluid, we think of liquid flowing around in a glass. So if you have a glass of water, you can see it sort of moves around. But the air is also a fluid. And we use physics to try to figure out where that fluid, where that air is going to be going. And so in those physical equations that we get from physics, we use quite a bit of math. And I really like math, and so that's a really fun part of my job. So some parts of my job use a lot of math, but there actually are other parts that don't use as much math, and we're using more sort of visual things, or a lot of chemistry as well, things like that.
Great. Michaela, getting back to the dust storms in Michigan, she wants to know, what are the negative health effects that result in breathing in the dust during a dust storm?
So in dust, the dust particles that come through the air are sort of bigger types of particles. They're maybe not, like dust in your house, which is really big particles, but they're bigger. And so when you breathe them in, they tend to get stuck in your nose, in your mouth, and in the top part of your sort of throat. And so because they get caught there, they can cause a lot of sort of breathing difficulties. You can get sort of a stuffy nose, it can be hard to breathe. And particularly for people who have diseases like asthma, it can really, really exacerbate or make worse. It can make your asthma a lot worse. And so for dust storms, makes it really hard to breathe. But there's some other health effects that people don't think of as much. So breathing the dust is bad, But also, when there's a lot of dust in the air, it makes it really hard to see.
Hmm.
And the big things that we really need to see far distances for is transportation. So driving, flying, things like that. And so dust storms often will cause car accidents on highways. The dust will come in and the people won't be able to see, and it'll cause car accidents. And it'll also can cause planes to not be able to fly because they can't see, so they won't be able to take off or land.
All very big issues, and you're playing an important role in helping to forecast those things. We've got questions now coming in from students in Miss Bound's class and Dorian Morgan as well. They're interested in the tools that you use to do this. What's the most important tool that you use, and what's your favorite weather instrument?
So probably the most important tool that we use are wind sensors. So the term we use for these wind sensors are anemometers. And anemometers tell us information about the direction the winds are coming from, but also how fast the winds are going. And how fast the winds are going tells us whether dust will actually come off of the ground. So we have your ground surface, and if you have a light wind, then, that soil won't really move. But as you get stronger winds, then the soil starts to move. And if you get really, really strong winds, then that's when the dust will be picked up and transported long distances. And then the direction of the wind is going to tell you where that dust is going to go. So is it just going to go into an area where there's no people and it may not have very big impacts, or is it going straight towards a city? So in Utah, where our dust comes from is from the southwest, and usually our strong winds also come from the southwest as they come. And so when the dust is picked up, it picks it up from the southwest and then moves it towards the big cities that are in Utah. So cities like Salt Lake City are located in that direct path of those dust storms. So that's probably the most important instrument. But I would say that my favorite instrument is our dust samplers. And these are instruments that I put out in the desert regions. One big area that I put out a lot of these instruments is the severe dry lake. And the severe dry lake has had water in the past, and you can see in this picture, during some of my studies, did have water in it. So this was an instrument trying to collect dust, but it wasn't collecting any dust at this point. It was just collecting mud and some water. So it wasn't actually what I was looking for, and that happens when you're doing science. But they basically collect the dust that's going in the air. And these are instruments that I actually have to go out to the desert and collect the dust from them. They don't do it automatically, which for me is actually really fun because I really like going out into the desert and exploring those areas. And so it's fun to go out and collect dust. Here's a great picture of me and my dog on a day where there actually were some dust storms. You might be able to tell it's a little bit windy, and we were collecting dust from those dust samplers.
Very cool. More questions coming in. This one from McCrae. Have you ever experienced being in a storm? And Shaw and Michael want to know, what's the biggest storm you saw coming?
Yeah, so I have experienced a few big dust storms. And in Utah, we get big dust storms about 4 or 5 times a year. And the biggest one was, I think, in March of 2010. And on that day, we had so much dust in the air that you could only see maybe half a mile or so sort of down the street. It was a lot of dust in the air. It had some really, really big impacts to a lot of people. So that was the biggest dust event that I've been in. But in thinking about weather in general, there are a couple other really cool storms I've been in. I've been in a hurricane in Florida before. That was sort of when I was younger, when I was growing up. I've also been in severe thunderstorms in Oklahoma where they get a lot of tornadoes. And I grew up in upstate New York. And in New York, they get a lot of ice storms where rain comes down and then freezes. And so I've also been in ice storms in New York. And so all of those different places have different types of weather and have sort of exciting kinds of storms. But each place has sort of different types of storms.
Makes sense. We've got a question now from Suzanne in Miss Bound's class. Can we control the weather at all? Will we ever be able to, for example, bring rain from flooding areas to areas of drought? And will we ever have ways to control or minimize hurricanes and typhoons? Hurricanes like the one that you may have been in Florida.
So we actually can do some small things that will change the weather. And so one of the big things that people do is when we have fog. So when we have fog, we basically have a cloud, and it makes it really hard to see. And at airports, this can be a problem. I talked about earlier that when there's dust, planes can't take off or land. But also when there's fog, planes can't take off or land. And this is a great picture of me and my mom, and we're actually in New Zealand. And there's this deck of fog below us. So we're up on the mountain, and there's this big area of fog below us. And when you have fog like this, it makes it really hard for planes to land and things like that. So what you can do is you actually can put these little particles, they're called silver iodide. And when you put these little particles into the cloud, it makes the water in the cloud want to turn to ice. And the water in the cloud sort of attaches to these little silver iodide particles and turns to ice and then actually falls to the ground. And so you can actually make some of the fog go away. So that's something that's done on a sort of small scale. But on sort of big scales, it's really hard to change sort of the weather. And so sometimes people use silver iodide to also try to change the amount of rain or snow that falls in certain areas. And most of those people don't have a lot of success. Sort of their success is mixed. Sometimes they have results that show that maybe they increased it a little bit, but other times they show that they can't really do much. So there's sort of small things we can do. Unfortunately, when we talk about hurricanes, because hurricanes are so big and such large weather systems, there is actually not much that we can do to sort of reduce the size or intensity of hurricanes. So to try to make sure that we're protecting us from hurricanes, it's more we're going to have to do stuff, where we live. So making sure people evacuate and making sure that maybe people don't live right on the coast where it's at the most danger of being hit by a hurricane.
So in that answer, you just mentioned being in New Zealand with your mom. We've got a question from Juliet that kind of stems off of that. Where have you been to study meteorology?
So most of my study of meteorology has been in the United States and in the Western US. So I've recently done a lot of work in Utah. I've also done some field studies in Arizona, where I was actually studying the weather in a meteor crater in northern Arizona. But I've also traveled some other places. I've traveled to Canada to collaborate with other meteorologists on how we can use our research to better forecast the weather. I've also gone to Europe, to France and Italy, to also collaborate with researchers there on mountain weather. So how can we better forecast the weather in mountains, which is actually a big challenge, because when you have mountains, it makes it a lot more difficult to figure out what the weather is doing. And this is a really cool photo of the Eiger. And there's this odd cloud sort of on the north face of the Eiger, and it's formed by basically the winds that the mountain itself are creating. And so because mountains actually create their own winds, they can sort of change the weather around them. And this is a photo of what we call a banner cloud. And the banner cloud coming off this mountain. So you see sort of the peak of the mountain poking up from the clouds. And then in this photo, the winds are actually coming from the right side. And so you're getting this banner cloud forming off of the left side of the mountain.
Very cool. In that last response, you were talking about collaborating with other scientists, so I just wanted to let Mrs. Heaney's class know we covered that one. And we have a group of students in Miss Bound's class with our next question. They want to know, what do teens find interesting about your work?
I think the biggest thing is sort of how weather impacts everyone, day to day. So I mentioned earlier that every day I look outside and I can talk about what's going on with the weather that day. But most people only really care about the weather when it's going to impact their lives. So maybe they want to go on a camping trip and then there's a big rainstorm coming that weekend. Or now we're going into the winter, and in the winter it's usually snow that's a real impact. And so I think really how weather impacts people and how we can, make sure people know what the weather is going to be like. So what the forecast is and what people should do with that information. So recently there was the really, really big lake effect snowstorm in Buffalo, New York. So lake effect snow is when cold air moves over a lake and it picks up moisture from that lake and also causes the winds to come together over the lake and creates heavy snowfall just downwind from that lake. And in this case, it was all falling over Buffalo, New York. And the meteorologists knew ahead of time that this was going to be a really, really big snowstorm. And so they were able to tell people that this snow was coming. And some people were able to prepare for that, and other people didn't prepare as much. And so it made it a little bit harder for them. So making sure people know about the weather and, figuring out what we can do to prepare for it.
All right, we've got time for just one more question in this segment before we move on, and this is a video question. It's from Cooper. Let's see what he has to ask.
Hi, I'm Cooper, and I live on Orcas Island, Washington, and I was wondering, how fast does rain fall as it's falling down from the clouds? Does it decrease in speed or increase in speed while it's falling down from the clouds?
So as rain falls from the cloud, it actually will at first get faster. So it will fall from the cloud, and due to gravity, so the gravity is pulling that raindrop towards the surface, it'll get faster and faster, but it won't keep getting faster the whole time. It hits something called terminal velocity. And terminal velocity is basically the speed at which some object, so it could be a raindrop or a snowflake or a rock or maybe even a meteor coming from space, it's what the speed that that object will sort of flatten out at, or that's the maximum it will reach. And that terminal velocity is related to the mass, or how heavy the object is, and it's also related to the size and shape of the object. So really small raindrops, their terminal velocity is actually not very fast. It's only about 5 miles per hour as it drops down towards the surface. But when you have a really, really big raindrop, the biggest raindrops we get, they sort of go a little bit faster and can go up to 20 miles per hour down towards the surface at their fastest speed. Once the raindrops get any bigger, though, and they maybe would start to go faster than 20 miles per hour, they actually start to break apart, and they break into a bunch of little raindrops, which will go a little bit slower. So about 5 to 20 miles per hour is where most of our raindrops fall towards the surface.
That is fascinating. And shameless plug here, Jason actually has a curriculum entitled Terminal Velocity. So go check that out too. Very cool. We're going to move on now. As I said before, we've been talking a lot about what a meteorologist is and what kinds of work you do in that field today, but we're interested now in how you got to be a meteorologist in the first place. So we're going to learn about your career path, and we have questions, lots of questions from our students out there who are interested in this. Students at Metrolina Academy want to know, when did you start liking meteorology? Students in Miss Bound's class want to know, how old were you when you started to be a meteorologist? And on a related note, Connor wants to know, what age were you when you discovered that you wanted to be a meteorologist?
So I've always loved science. So from when I was, a little kid, I knew that I wanted to be a scientist. But growing up, sort of my problem was I just loved all kinds of science. I wanted to study everything. But as I got older, and particularly when I was deciding where I wanted to go to college after I was graduating from high school, I realized that I had to maybe choose a certain area of science to focus on. But it was a hard decision. So I was actually watching TV one day and I saw a TV meteorologist, so someone who was forecasting the weather on the TV news. And I had this idea that that would be a really fun job. So I also grew up loving science, but I also grew up loving acting and theater and being in plays and musicals. And I thought that being a TV meteorologist would sort of combine those two things I really liked. So when I was a junior or senior in high school, I started looking for universities where I could study meteorology. And so that's where I sort of decided, yeah, that's what I want to study. When I first started studying meteorology was when I was in college. And it was actually pretty quickly when I was in college that I decided that I actually didn't want to be a TV meteorologist, but I still really, really liked meteorology and weather. So I kept studying meteorology and decided to do research and teaching in meteorology instead of being on TV. But being on TV still is a really cool job. I have a couple friends who are TV meteorologists.
I know a couple things about being on TV. Not exactly TV, but it's webcasting, and it has its moments for sure. We're going to actually hit a couple questions that you kind of touched upon in that last answer, but let me see if there's anything a bit deeper that you want to add to that. Layla wants to know who inspired you to become a meteorologist. Kenzie wants to know, was there anything else you wanted to do besides meteorology? And Armita wants to know, what was your favorite subject in school?
So I'll start with my favorite subject. So my favorite subject in school was always science, but also I really liked math as well. And I really liked that, basically every year or even within a year, we learn about all different kinds of science. And as I was growing up, I knew I wanted to be a scientist, but I wasn't sure what kind. And one of my sort of early ideas was that I wanted to be a archaeologist. And I came up with that idea because of the movie Indiana Jones, which maybe you kids haven't seen, but when I was growing up, Indiana Jones was really, really popular. And so I saw Indiana Jones and I'm like, that looks like a really fun job. Maybe not the more adventure stuff, but that looks sort of scary. But being a meteorologist an archaeologist and looking for sort of ancient things. But later on, I sort of changed and thought I would maybe do more stuff about earth science. And so really, I think who inspired me to be a meteorologist really was sort of the TV meteorologists I saw growing up. And I really liked how they actually on the news got to talk about science, because usually on regular local news, they're not talking very much about science on a day-to-day basis unless there's a big, science-related news story. And so the only person who's giving you science sort of every day on the news was that meteorologist.
It's a great answer. We've got a couple of potentially related questions here. Sixth grade girls of Mrs. Walter's class say, You said that when you were getting your education, there were very few women in your classes and no female professors for meteorology. Have you noticed much change in this trend? And Aisha wants to know, what were some challenges that you faced in becoming a meteorologist?
So I think the number of women in the meteorology classes has definitely increased, and especially in other sciences, physics, chemistry, biology as well, and geology. There's more and more girls and women that are going and taking those classes. The other part of that, the first question about the number of professors, the number of professors is slowly increasing, but it's actually still not really high. And that was part of the reason where that I decided I wanted to be a professor and be a teacher of science and meteorology. Because I wanted to sort of show students that yes, if you're a girl, you can be excited about and be interested in meteorology and science and go into that field and sort of be a role model. And some of the challenges that I've had, one is sort of trying to make a research project um, work from the beginning to the very end. And it's a really long process, and there's a lot of steps involved. And as you move through the process, there's a lot of challenges. So at the beginning, you usually need to get money to do a research project. And sometimes a lot of the money that we get are from grants from the government, or maybe from private companies or foundations, and it can be hard to get that money. And so I actually had some projects that I wanted to do, and I couldn't get the money to do them. So I did other things that I could get some funding for. So that's one problem. And then the other problems come in, when you're actually doing your research. So my research was on dust storms in the western US. And the first part of time I was studying this, there was a lot of dust storms. So I had lots to study. But then we had really, really wet years. There was a lot of rain and a lot of snow. And so the dry lake I was studying turned into a wet lake. And the wet lake, now it's covered in water, it's not going to produce dust anymore. And that was a really exciting thing that happened, but also it wasn't really what I was looking for. And so sometimes when you're doing research and science, things don't always work out perfectly. So here I had to, wade in the water to collect my dust samples or my mud samples. So not ideal, but you work with that, and you are usually able to come up with some good results anyway, even if it wasn't what you were looking for. So it's challenging, but in the end, you usually can come out with a good result.
Okay, we're going to take one more question in this section, not exactly related to your career path necessarily, but you've talked a lot about meteorologists on TV, and Anna wants to know, are they real, or are they told by real meteorologists what to say? Are they just the pretty face and the talking head on TV?
So it actually used to be that most of the people on TV who were talking about the weather were not meteorologists. So they were just sort of using the forecasts that actual meteorologists did, and they're talking about them. But that has changed a lot over basically the past 20 or 30 years or so. And it's out over time, more and more news stations were hiring actual meteorologists. And so now, most of the people you see on TV that are talking about the weather are actual meteorologists. And sometimes, if you're watching, you might see that they may actually have a little symbol next to their name. And that little symbol next to their name is saying that they are a certified TV meteorologist. And there's a couple organizations that do that certification, but it basically tells you that yes, this person is a meteorologist, they know what they're talking about, and they're not just sort of the person talking about it, but not actually doing the science.
I have not noticed that symbol yet. I'm going to have to keep an eye out for it now. as I said before, we're going to move on now. You guys have been asking a lot of questions, sending Maura's way, but now she has some questions for you. It's time to do our polls, and here's the first one. These were created by Maura to test your knowledge of meteorology and dust storms, and here the first one is, what is the biggest source of dust storms in the world? Is it A, the Sahara Desert? Is it B, the Gobi Desert? Is it C, the Amazon rainforest? Or is it D, the Great Basin Desert? And while our audience is answering these, or taking a guess at what the biggest source of dust storms in the world is, Maura, why don't you tell us where each of these are, just in case folks aren't too familiar with the various areas?
Yeah, so the Sahara Desert is in sort of the northern part of the continent of Africa. The Gobi Desert is in western China, sort of central Asia. The Amazon rainforest is in the central part of South America, and then the Great Basin Desert is in the western United States, in the states of Nevada and Utah.
Very cool. Well, we have answers actively coming in as we speak. Right now, the Sahara Desert is well in the lead with about 60% of the vote. Great Basin is in second place with 27%. I think this is probably a good time to wrap up the voting, but Maura, why don't you tell us which is the correct answer?
So everyone did a good job. The Sahara Desert is actually the biggest dust source in the world, and it's actually much bigger than most other dust sources. And the big reason for that is it's much larger than a lot of other deserts. In the Great Basin Desert, I put it in there because that's where I study dust storms. But actually, it's one of the smaller dust sources in the world, but it is important sort of in the region that the dust storms occur.
Great. Our next poll question here, possibly one of my favorite poll questions of all time for the STEM Role Model series, just because I love this word. What is a haboob? Is it A, a high thin cloud? Is it B, heavy rains that occur during certain times of the year? Is it C, the destruction path of a tornado? Or is it D, a type of dust storm caused by thunderstorms? Now, I don't think have we talked about haboobs at all in up to this point in the program?
I don't think so.
So this could be totally new for them. I'm trying to think if you talked about that at all when you answered your profile questions. Not sure. So I'm not sure if our audience has too much to go on here other than just kind of their general knowledge of weather and meteorology. Let's take a peek at the answers that are coming in. So far, a type of dust storm is way ahead in the lead. That's about 86% of the vote. I don't think any of these other options have any chance of catching up to that. Now it's almost 90%. Maura, why don't we just jump to what is the correct answer here? Are they right?
So you guys are all right. The correct answer is that it is a type of dust storm caused by thunderstorms. And I actually don't study haboobs very much. I have a lot of colleagues that study haboobs. My dust storms are formed by large cyclones, but haboobs are a type of dust storm caused by thunderstorms. And when the thunderstorm rains, as the rain comes down, it creates cold air that sort of rushes out from the bottom of the thunderstorm, and those the strong winds as the air rushes out from the bottom of the thunderstorm picks up the dust. And haboobs are really dramatic because as they come in, you get this almost like a wall of dust coming in towards you, and so it can be kind of scary looking. And those are really common in areas like Phoenix, Arizona, and also really common in the Middle East, which is where the word comes from, haboob.
Makes sense. All right, we're going to pretty quickly go through poll question number 3 here. In which of the following locations did Maura once study atmospheric temperature and winds? Is it A, Mount Rainier, Washington, B, Death Valley, California, C, Barringer Meteor Crater in Arizona, or D, Yellowstone National Park in Wyoming? And I think I can give a little bit of a hint here, Maura, that we have definitely talked about this during the event. So if people are paying attention, and I don't think we mentioned any of the other options, they should probably get this one right. Folks are voting now, and I am going to try to make sure that well, we're not going to be able to actually see the votes come in, but I can tell you right now that 70% think it's Barringer Meteor Crater in Arizona. Are they right, Maura?
Yes, they are right. So yeah, I mentioned earlier that I actually studied basically the weather inside of a meteor crater, and it was a little confusing for some people because it has the word meteor in it, and so I'm saying that I'm studying, a meteorologist studying a meteor crater, but I wasn't studying actually the meteor that caused the crater. I was studying the weather. And the term for people that actually study meteors is meteoricist. So maybe it's the meteorologist stole that word, so meteoricists had to come up with a different one for their research.
So do you know the history of why a meteorologist is called a meteorologist?
Yes, so it comes from the word hydrometeor. So hydro is for water, and meteor is things that fall from the sky. And so a hydrometeor is water falling from the sky, which is basically rain, snow, hail, things like that. And so when meteorologists came about, I guess they dropped the hydro part since maybe they thought it would be too long, and so it turned into just meteorologist.
That's fascinating. I had no idea. But it certainly makes sense. We are going to move on now and think about the future. And in this segment, we're going to talk about Maura's future, but also the future of all of our students out there. And we've got a couple questions to get us kicked off in this segment. Monica wants to know, who do you hope to inspire in the future? And Tristan asks, how does a student like me get even more excited about science? What do you have to say about those?
So the people I want to inspire, which is part of the reason I am in the job I'm in now, is students. And so right now I'm teaching college students, and I really want to inspire them to be scientists and maybe be meteorologists, but also to, even if they're not going to become scientists, to have an interest in science and how it affects their day-to-day life. And then, what was the second question?
The second question was, how does a student, like our viewers out there, get even more excited about science? And I'm going to go on the assumption that they are pretty excited about science to begin with.
So I think there's sort of two things. So one is to really just observe what's going on in your day-to-day life, and weather is a great example because weather is always changing. So when you go outside and you see a cloud or it's snowing, think about, why that's happening, and maybe look at the news and see what they're talking about it. And then maybe go online and you can look at the National Weather Service, and they have radar data and satellite data and temperature data that you can look at, and you can actually sort of be your own meteorologist. And so sort of, doing things, looking at your own environment and, being curious about it is one way. The other way is to sort of, find scientists that you are interested in. And a lot of those scientists are now on social media. They're on things like Facebook and Twitter. I am on Twitter. You can follow me on Twitter, or other scientists that you're interested in, or organizations that talk about science. And you can see what's going on in science right now. What is the, cutting edge research or things that are happening?
Very cool. And why don't you plug your Twitter handle just so people know where to find you?
So my Twitter handle is Dr. Maura, so DRMAURA_science.
There you go. Our next question from Brianna. Do you encourage kids like us to try your job when we grow up, and why?
Yes, definitely. So, like I said, weather is always happening, and so there's a lot of opportunities in how people can be involved in meteorology. So you can be a weather forecaster, or you can also be, a teacher, a professor like I am. But there's also a lot of private companies that need weather information all the time. And so uh, there's a lot of really fun things about the job. And so I definitely encourage people to explore meteorology and, what a career in meteorology might be like.
Great. We are going to go pretty rapid fire just because we have a few minutes left in the program. Want to get as many questions answered as we can. Here's two more. What do you hope to achieve in this job, and what kinds of challenges do you set for yourself?
So I'll sort of answer some of them together. So one thing I am hoping to achieve, and is sort of a challenge for me, is I want to create actually a degree program. I'm at Salt Lake Community College, and I want to create a degree program in meteorology, and it would be one of the only associate's degrees in meteorology in the country. So that's what I'm trying to work on right now, to have more meteorology classes and sort of have a better program. And then also, I want to do research that is really going to help people.
All right. We're going to move on once again, and now we're actually going to talk about. We're not going to talk about your job at all. We're just going to talk about you and your personal life. We've got some questions from kids about that. And let me bring up the first one. That is the wrong mouse. Here's the right mouse. George, Bill, and Odell want to know, what was your favorite hobby as a kid?
I would say my favorite hobby as a kid was probably doing theater. I was sort of a theater nerd. I really liked acting and singing and dancing, and I did a lot of all of those things.
Dovetails very nicely into a comment from Miss Hale's class. I read that you liked drama in school. Do you still like to participate in acting?
Yes, I do. And I haven't mentioned this before, but being a teacher and a professor, it's not that you're acting, that you're pretending, but you still are getting to, be up in front of a group of people and sort of present yourself. So there's a lot that about teaching that is similar to acting. But other than that, I do still do quite a bit of performing. Um, I've transitioned more to singing, so I do a lot of singing performances instead of acting, but it's still really fun.
Very fun. Jabeen wants to know, were you the nerdy one in the family?
I would say no. And the reason I say no is like I think my whole family is a little bit nerdy. So my mom was actually a college professor in sociology and anthropology. My dad was a high school math teacher, and my brother is a mechanical engineer. He actually does engineering for a snowboard company. And so all of us were really interested in science and learning, and we all still are. And so I think it makes it fun. We can all be nerdy together and do fun stuff.
You fit right into the family. Jackson and Xander want to know, how do you spend your free time?
I would say a lot of my free time I try to spend outdoors, and which is nice for my research because my research is also outdoors. But I love hiking and skiing and river rafting. This is a great photo of me and my mom hiking in New Zealand. And so being outside is really the thing I like to do.
Xavier is next. He says, I see that you have a dog. What kind of dog do you have, and what is his name?
So he is a border collie, and he is a great dog. And his name is Roscoe, and I like to tell you his full name is Roscoe Holcomb Wholesome Folsom.
All right. I don't know how we're going to top that, but we're going to move along into just our last round of rapid fire questions. Here's a comment from Hambright Elementary 6th grade. We loved watching you dance your PhD. You mentioned that in another career, you could see yourself acting in a science fiction film. If you could take what you are currently researching and turn it into a science fiction film, what would the plot be? So there's a lot going on here. First of all, for viewers that are not aware, can you tell us what Dance Your PhD is? And we're going to watch it while you're telling us. And then you can get into the science fiction thing.
Okay, so Dance Your PhD is a competition where I basically ask people getting their PhDs in science or in other fields to basically take their research and turn it into some sort of dance. So this is a video of me and my friends. I luckily was able to convince a bunch of my friends to go out to the mud flats around the Great Salt Lake. We sort of do this dance that it tells the story of dust in western Utah. And so think about from a science fiction film using my research. Well, it would have to be about dust storms, but maybe instead of dust storms on Earth, we could do something about dust storms on Mars. And the music in my Dance Your PhD was actually a piece called Mars, classical piece. And so in Mars, there's also dust storms. So it could be a science fiction film where some astronauts go to Mars, maybe to search for water and life, and are, impacted by these crazy dust storms that occur there.
I have to. That is some pretty quick thinking in response to that answer. So great job. Unfortunately, we have run out of time. There are lots of questions that kids have that we have not been able to ask, but we really appreciate you taking the time today and answering so many of the questions that you did answer. It's been great learning alongside you and our audience. So thanks for joining us today.
Thanks so much for having me.
Awesome. So just want to say that this is actually the last live event of the 2014 calendar year. We're going to take a break for the holidays and wish you a very happy holiday season. And we'll be back in January with a whole new round of inspirational STEM role models. So we hope you join us there again. Keep an eye out on our Twitter feed and on our Facebook account as well, and we'll let you know when to expect those and who's coming up next. Until then, for Jason Learning, my name is Patrick Shea, and we'll see you next time on Jason Live. Take care.